Systems of equations. Systems of equations here. I'm going to take this system of equations. We know it's a system because we got two unknowns and two variables that are two equations that set up the system. Okay? And so in there, I'm going to work this three ways because you're given your option to work it any way you want. Okay? And I think on the test this confused you because it had a graph down at the bottom and you thought you should graph it. Well, first of all, I would strongly suggest if you're going to graph it to use your calculator because your hand graphs are not good.
How does that work if you use your calculator? How do you transfer that over to your headers?
You should be able to draw your calculator screen on there of some form. But the problem was that you're supposed to be able to use the graph to create the point of intersection, but the way that we hand draw them is not going to be accurate. So, another thing is there's two things that we went over yesterday that I had you write down on your paper. That's the key point of emphasis that you should walk away from the system of equations. First of all, the solution to the system of equations is?
Point of intersection.
Very good. And the point of intersection is created by the? Very good. If you know those concepts, you have a fighting chance. If you don't know those concepts, then we probably need to start over. Okay? And so, what I'm going to do is I'm going to work these three different ways because you have the option to do so. But I'm also going to talk to you about if I was working this problem, why I would do it this way. All right? First of all, this is in standard form. Everything's in standard form. First characteristic of the problem. Second characteristic of the problem is that it has two coefficients of 1, and actually one of them is the opposite. So therefore, this lends itself to elimination. Standard form, coefficient of 1. I didn't have to worry about like coefficients because I have a coefficient of 1. All right, and so I'm going to use elimination first. Okay? So let me bring them down. And what I'm going to do here is I'm going to eliminate the y. And if I eliminate the y, I'm going to multiply through by 2. I'm going to bring the top one down because it did not change. And the new equation for the bottom became 2x minus 2y equaled to 26. Okay? And now I add those together. This becomes 6x. My y's are eliminated. Equals 36. Solve for x by dividing by 6. X will equal 6. Alright? And now for me to find the other one, I'm going to substitute it back in. It doesn't matter which one I substituted in. I should still get the same answer for both. Oh, there we go. And so now then, I'm going to subtract the 24. Okay, so I have 2y equal to negative 14. Divide by 2. Y is going to equal negative 7. So the solution to this systems of equations is what?
6, negative 7.
As a
Point.
Of?
Intersection.
Beautiful. It's beautiful. All right? And so now, elimination lends itself, you're going, I don't want to work it that way. That's a lot of work going down through there. Yes, but you know the work that you mess up on the most is going to be the last one I'm going to do is graphing and moving things across the equal sign. I can even tell you the mistake that you're about to make and you'll still do it. I witnessed that. Okay? You just don't pay close enough attention to details to move variables across the equal sign to set it up in the right form. So the next way I'm going to do it is substitution.
Is graphing your least favorite?
It is for you guys right now because we don't pay attention to the signs. Okay, most students like graphing because they feel that this does all the work, and it really doesn't. You've done all the work by getting the variables by itself, and so therefore, all it's doing is just drawing them. So. I think you got to start with graphing, because if you can't establish that the solution is the point of intersection, first of all, you don't have a point in elimination. You don't have a point in substitution. You create a point in graphing because it's all based on coordinates, so therefore you get a clear understanding of the point of intersection being the solution. And so it's not my least favorite, it's just the one I think you're going to make the most mistakes on. All right, so for substitution right here, I need to get a variable by itself. I can do that through any of them. But I need to examine the problem and know which one would be the easiest. I don't want to move the x over here because then I'm going to divide by the negative on the y, which most of you won't bring down with you, and you'll just be like, oh, I'm done. If I do it up here, there's a possibility of fractions. It may not, because they're all divisible by 2, but I have the opportunity for fractions if I have coefficients in all 3 places. Okay? And so I've got to examine which one would be the easiest to get in substitution form. The top one is not the easiest one to do that, or not the easiest one that jumps off the page to me. The easiest one is if I move this y over by doing the opposite, I have x by itself with nothing else. Okay, and so this is the one that I'm going to get in substitution form. Just like that. And so therefore I'll take the original and I'm going to substitute in for x, y plus 13. Now those of you that struggle with your order of operations, this may not be the one that you want to do. Okay, so we got to take care of our parentheses. Nothing can be done. There's no exponents. So my multiplication is distributing to 4. No, 52. All right. I combine my like terms. Now I'm solving. Okay? And there we go. So now I'm going to take my y and I'm going to substitute it back in for my y. One other issue that you make right here is you don't do that negative and negative to make that positive 7. It's one. I mean, it's not a hard step, but it's one that we forget sometimes. And x equals 6. Is that the same solution as the first one?
Yep.
It is, so we're good. And lastly, we are going to do graphing. Okay? And in graphing, I got to take the original equations and I got to get them into slope-intercept form. All right, so here's my original. I need to solve for y. So I subtract the 4x. That step, none of us really have an issue with. Yep. Next step, we're going to divide everything by 2, but the problem that we have right here is sometimes y'all do not divide everything. Correct? So there's my first equation that I'm going to use in graphing. All right? Now, this next one, which is more simple in getting solved for, allows itself for the most common error that we make.
Because we need the negative y.
There you go. What we do right here, y'all do that step correctly, but when I bring it down, you bring it down just like this right here. You leave the negative off the y. Most common mistake that I saw in your test is that you will not bring that down with you. If it's plus, it's fine. You don't have to bring it down with you. But being negative, you have to, because right here I have to divide by negative 1. And so my new equation is x minus 13. Correct? All right, so now let's do this in my calculator. Those are my two equations.
2 negative 2x plus 9.
All right, and so what I'm going to do is I'm going to go into my y equals. It's going to be negative 2x plus 5, and then it's going to be x minus 13. Graph. Can you see the point of intersection?
Now you gotta zoom
I can see it right here, right? All right, I can see it. So since I can see it, I'll go second, trace. Second, trace. I'll scroll down to intersect. And all I need to know is that my blinky things have to be on the other side. Other side of my point of intersection. And therefore I get 6.
When you get on the other side of the intersection, do you click enter and it gives you that?
And then it's going to ask you to guess. And they just want you to try to see if you can put the cursor where you think the point is. We ain't got time to guess. Just hit enter and roll through because we got more problems to work than this one. Okay?